All right, let's take a look at this warm up here. According to the Survey of Study Habits and Attitudes, the academic motivation of study habits of females as a group are better than those of males. Shocking. The distribution scores among women at college has a mean of 120 and a standard deviation of 28. The distribution of scores among men at a college has a mean of 105 and a standard deviation of 35. If you were to select a single random male student and a single random female student, what are the expected value and standard deviation of the difference between their scores? All right. So female is a random variable that has a mean of 120 and a standard deviation of 28. Men is also a random variable that has a mean of 105 and a standard deviation of 305. So this is basically saying what's the expected value of female minus male, which is the same as just the expected value of the females minus the expected value of the males. So don't overcomplicate this. It's just 120 minus 105 for an expected difference of 15 points. Now the standard deviation of the females minus the males is a little trickier because this is where we have to add the variances. Even though we're subtracting the variables, we add the variances because things become more spread out. So it's 28 squared plus 35 squared. Now that's going to be a variance, so we have to take the square root to turn it back into a standard deviation. All right, kind of looks like Pythagorean theorem. So square root of 28 squared plus the square root of 35 squared gives us a new standard deviation of 44 point, we'll say 8219. We'll go 4 decimals this time, 8219. So using your numbers from above, what is the probability that the woman you select will have a higher score than the man? So we're basically saying, what are the odds that when you subtract this, you're going to get a positive number? Or put another way, what are the odds that the value that you get after subtracting these two numbers is going to be 0 or higher? All right, when the mean is 15 and the standard deviation is 44.8219. All right, so if the mean is 15 and we're saying 0 and above, we automatically know this is going to be higher than 50% because 15 and above would be 50%. So if we're starting at 0, we should get something above 50%. And we are exactly going to get 0.999 when the mean is 15 and the standard deviation is 44.8219. We're going to end up with 0.6311. All right, so 0.6311. And that's the probability that the woman that you randomly select is going to be higher than the man that you randomly select. Because again, just because the average is higher doesn't mean every single woman is going to be better than every single male. Obviously, there's going to be some variation there, but 63% of the time you would expect that the woman you grab is going to be higher than the man you grab from the pool. All right, let's pretend the weight limit on a 3-person ski lift is 800 pounds. I have no idea what the real number is. If the mean height of skiers is 175 with a standard deviation of 30 pounds, what's the probability that any 3 random skiers would exceed the weight limit? So these sometimes goof kids up because they don't get like separate random variables, but effectively what you're doing here is x1 plus x2 plus x3. And they just all have the same mean of 175 and the same standard deviation of 30. So the expected value of x1 plus x2 plus x3 is just 175 plus 175 plus 175. Or put another way, 175 times 3. 525. So that's going to be the average amount. Now, we've got to find their new standard deviation. And again, we don't just get to add the standard deviations, we have to add the variances. So that's 30 squared plus 30 squared plus 30 squared. But we don't want the variance, we want the standard deviation. So we have to take the square root to turn that back into the value we actually want. So we're left with the square root of 30 squared plus 30 squared. I could have just done 30 squared times 3. But anyways, 30 squared plus 30 squared plus 30 squared, 51.9615. 51.9615. Now that we have these two numbers, we can answer the question, what's the probability that they would exceed the weight limit? Well, the weight limit for 3 people on the chair is 800 pounds. So we're saying, what are the odds that you're going to be 800 or higher when the mean is 525 and the standard deviation is 51.9615. And hopefully this is going to be really low, because otherwise you should probably not get on a ski lift. All right, so 525, 51.9615. And we can see that it's e to the negative 8th. So that's really 0.1, 2, 3, 4, 5, 6, 7 zeros. And then the 6049. Right, which is what we'd hope. All right, we'd hope that there's a very low chance of there being a problem on the chairlift. All right, and that's what we're finding when we do this calculation. All right, but again, this idea of finding your new mean, finding your new standard deviation, using those inside of an NCDF. All right, let's keep going on this. The amount of nitrogen oxides present in exhaust of a particular type of car varies from car to car with a normal distribution that has a mean of 1.4 and a standard deviation of 0.3. 2 randomly selected cars of this type are tested. One has 1.1 grams of NOx, the other has 1.9. The test station finds this difference in emissions between the 2 cars surprising. If NOx levels for 2 randomly chosen cars are independent, find the probability that the difference is at least as large as what the attendant observed. All right, so this is what was observed in real life. All right, what was observed in real life was the 1.9 minus the 1.1 or 0.8. All right, that was the gap that we observed in real life. Now, in theory, the cars should have been the same. All right, this should have been an x1 minus x2 type situation because they're both coming from this same distribution. All right, they're both coming from this same mean and standard deviation. So the expected value of x1 minus x2 is just 1.4 minus 1.4 or 0. All right, that's what we would have expected to see because they're coming from the same population. Now, the standard deviation of x1 minus x2, remember, even though we're subtracting, we still add the variances. So it's going to be this 0.3 squared plus 0.3 squared, and then we're going to take the square root to get it back into a standard deviation. So we've got the square root of 0.3 squared plus 0.3 squared, and we get a standard deviation of 0.4243. All right, so now that we have these values, we can say, all right, what are the odds of getting a difference at least as large as this? Now, I got 0.8 because of the direction that I subtracted these, but I also could have gotten negative 0.8 if I had flipped these. So I have to test both of those and add them together. It's going to be 0.8 or higher when the mean is 0 and the standard deviation is 0.4243. And it's going to be the same thing in the other direction. So either above 0.8 or below negative 0.8. Now, again, because this is centered at 0 and the normal distribution is symmetric, these two are going to give you the same answer. So you can always just do one and double it because they're going to give you the same answer. But if I go here and I say, all right, 0.8 to 9999, when the mean is 0 and the standard deviation is 4243. All right, there's that. Now, if I flip this around and go negative 9999 and negative 0.8 and keep the mean and the standard deviation, I'm going to get the same thing. So I can always just double those and get my final answer that way. So you basically end up with 0.02968, we'll say. All right, and that's both of these. So then if we multiply that by 2, we can get our final answer. And again, you're going to get slightly different answers depending on how you round this, but I'm just going to say 0.059. 368, we'll say. 368. All right, so either above 0.8 or below 0.8, you're going to get this same answer. So you either just add it to itself or you just do it once and say that I'm multiplying it by 2. But either way, same idea. Find the mean, find the standard deviation, put it in CDF. It's just recognizing that, like, okay, these are coming from the same distribution. So I just use the 1.4 twice. I use the 0.3 twice. All right. So a little trickier because they don't give you as much, but same structure once you realize what it's asking. All right. A company's single serving cereal box advertised 9.63 ounces of cereal. In fact, the amount of cereal in a randomly selected box follows a normal distribution with a mean of 9.7 and a standard deviation of 0.03. Let y equal the excess amount of cereal beyond the advertised amount in a randomly selected box. Y will be measured in grams. Find the mean and standard deviation of y. All right, so this is actually one of the old style problems. All right, we're not combining random variables here. We're doing two transformations. All right, we are subtracting $9.63 to find the excess. And we are, if we're converting from ounces to grams, 1 ounce is 28.35 grams. So we are multiplying by 28.35. All right, so this is two separate transformations. So the subtraction is only going to affect the mean. All right, so this is only going to affect the mean. And the mean is going to go from 9.70 ounces to 0.07 ounces. All right, so this one is still in ounces. The standard deviation doesn't change. All right, it is unaffected by adding and subtracting constants. So when we get over here to the multiplying by 28.35, this affects both the mean and the standard deviation. So we're going to take this 0.07 and multiply it by 28.35. We're going to take this 0.03 that we started with and multiply it by 28.35. So this one only impacted the mean because we were adding and subtracting a constant. This one impacts both. And these are going to be our final answers because this is, we've converted it over to grams. So 28.35. So this is going to be 1.9845. This is our new mean. And And then this one over here, the 0.03 times 28.35 is going to be 0.8505. And this is our new standard deviation. All right, so again, adding and subtracting a constant only affects the mean. Multiplying or dividing by a constant affects both. Now, number 6, using your numbers from above, what is the probability of getting at least 3 extra grams of cereal in your box? So that's just saying, okay, now that we've got these two values, what's the probability of getting 3 or more when the mean amount that you're getting extra is 1.9845 grams and the standard deviation is 0.8505 grams. So we can go to our normal CDF there. We can say 3 to 9999 when the mean is 1.9845 and the standard deviation is 0.8505. All right, put those in. We get 0.1162, we'll say. So again, this one, we're not combining random variables, so we didn't have to do this stuff over here, but we did have to know our rules for constants and how they affect it, and then we're plugging it into NCDF like we have been for all the others. All right, so hope this was helpful. Obviously, if you had any questions, just reach out and we'll go from there. All right, bye.